Alright, let's hope this is recording. It doesn't show my headset as being plugged in. I better check on that. We're just going to take our chances. Hey guys, we are talking about systems of inequality. So basically, all you're going to do is exactly what we did with systems of linear equations. You're going to put two lines on a graph and see the regions in which they cross. So the first one we're going to do is y minus 2x is greater than 1, and negative x minus y is less than or equal to 2. So as you know, we have to solve both of these for y, get them into slope-intercept form before we can do anything else. So I'm going to add 2x to both sides, except I didn't. I said add 2x to both sides, but then I didn't do that. Okay, and I like to, once I solve an inequality, I like to get it on the graph so that I know it's done. So I'm going to start at 1 on the y-axis, go up 2 over 1. Remember, this is a dotted line because there's no line underneath. And then we're going to pick a point to decide which way to shade. 0, 0 is not on the line, so we're going to check 0, 0. And this says 0 is greater than 1, which is not true in this lifetime. So we'll shade away from 0, 0. And that is this linear inequality. The problem is we're doing systems, which you know means 2 equations and 2 unknowns. So we need to now solve this inequality and put it into slope-intercept form. I'll do this one in blue. I'm going to add x to both sides. So I have negative y is less than or equal to x plus 2. I don't care about negative y, I want to know about y, so I'm going to divide by negative 1. And remember, when you divide by a negative, flip the sign over. Alright, so we're going to start at negative 2 on the y-axis, down 1 over 1. Remember, if you have a negative slope, your line should be going downhill. This is going to be a solid line because there's a line underneath. And now you can see, wow, that's a bad line. Now you can see why I have you draw straight lines for your shading, because watch what happens. So check 0, 0. 0 is greater than or equal to negative 0 minus 2. 0 is greater than or equal to negative 2, which is true. So now we're going to shade this way, and it's very clear to see where your two shadings cross when you have straight lines. So this is your solution set. Now the question in your book will say, give a coordinate within the solution set. So all you do is pick one of the points where my big S is drawn. Looks like negative 1, 5 ought to work. And remember, you can plug that into both of your original inequalities and show that it is true for both of them. But that's all we do for a system of linear inequalities. We just put 2 lines, shade, and see where the shadings cross. Let's try one more. I had a graph here. Where did it go? Oh my goodness. Oh, what's going on? Oh no. Ah! I have no idea what's happening right now. I'm sure this is really enjoyable for you to watch me fight over this project. Okay, there's that one. Where is the next graph? There it is! Woo! We made it. Okay. Oh, let's try this one. Looks fun. Negative 2y is less than 4x plus 2. To solve for y, I'm going to divide by negative 2. Remember, when you divide by a negative, you flip the sign. 4 divided by negative 2 is negative 2x. 2 divided by negative 2 is negative 1. So we'll start down here at negative 1. We'll go down 2 over 1. We're talking about a dotted line because there's no line underneath. Sometimes it helps if you go through the points on your line. Just keep in mind I'm trying to do this on a computer and it's not really all that good. Okay, so check the point 0, 0. 0 is greater than negative 2 times 0 minus 1. 0 is greater than negative 1. True story. So we're going this way. Straight lines. Now this other one is tricky. Y is greater than the absolute value of 2x plus 1. Whew. Okay, so we didn't really talk about graphing absolute values with a number right here. So if you ever come across a graph that you're not sure how to do, just make a table of values. I'm going to go from negative 3 to 2. Negative 3. 2 times negative 3 is negative 6, plus 1 is negative 5. The absolute value of negative 5 is 5. Negative 2. 2 times negative 2 is negative 4, plus 1 is negative 3. The absolute value is positive 3. Keep in mind, I just picked arbitrary numbers here. I had no idea what these numbers were going to look like. Plug in negative 1. 2 times negative 1 is negative 2, plus 1 is negative 1. Absolute value is positive 1. 0 is also positive 1. 1 is 3, and 2 is 5. So it looks like this. Oh, geez. Negative 1, 1. That doesn't make sense. Oh, yes, it does. Oh, no. Negative 2, 3. So we know absolute value graphs look like a V. And this one just happens to be a V whose point is at a fraction. But that's okay. It should be dotted because it's not equal to. So I'll just make little... There, now it's dotted. And pick a point. 0, 0. 0 is greater than 2 times 0 plus 1. Absolute value. 2 times 0 is 0, plus 1 is 1. 0 greater than 1? No, it's not. So I'm going to shade inside. So this is my solution set right here. Okay? So this is just a quick video. I'm going to give you problems to do for homework. This is just a quick video to guide you in doing those problems.